Everyone, welcome back. Today is Thursday, March 26th, and this is the new lesson for today. So today's video is going to be just a little bit longer, not too much longer than the other ones, but just a little bit longer. All right, but that'll be okay. So I hope everyone's doing all right. Not too many of you have emailed me with too many questions or texted me with my Google Voice, but I'm here. Okay, I'm here all day. All right, not just during regular school hours, but pretty much all day. All right, so let's get started. This is a new part of the same packet that I emailed you, or I should say I attached to assignments. But this is a new part that you may not have yet, okay? So I've attached a new piece. Anyway, let's start with sorting. What is sorting? Okay, so sorting means to arrange. Right? So if I want to sort, if I want to sort different hamburgers, let's say, right? I'm going to have all the McDonald's hamburgers over here, and then all the Burger King hamburgers over here, and then all the Wendy's hamburgers over here, right? So I'm going to arrange them according to some kind of feature, right? All right. So sorting here, in terms of weathering, erosion, deposition, means arranging sediments. According to what? Well, according to size and weight and density, those kinds of things. So if you look over here in our packet, I have here what says sorted sediments right there. You can see that they are arranged in order. So that's what sorting means. We're going to talk about a couple of different things. We're going to talk about running water, which is like streams or rivers, and then frozen water, which is ice, right? So that would be a glacier. We're going to go into what a glacier is in a little bit. Okay. Here we are. Let's take a look here. We have a stream that flows into a lake, okay? And notice that the sediments that it was eroded by that stream go into the lake. And because it's flowing water, it's a flowing stream, liquid water, it arranges the sediments according to size. In this case, also weight, right? The bigger one would be heavier, the smaller one would be lighter, right? Okay. You should know now that the larger sediments would be like cobbles and boulders, and the smaller sediments would be clay and sand and silt and those kinds of things, right? We already went over that. Good. All right. So you can see here that the speed of a stream's flow slows down as it enters a larger body of water, like an ocean or a lake, right here. Okay. So that flowing water, the amount of water that's flowing through the stream right here, right? The amount of water is called the stream's discharge, right there. Right here it says the amount of water flowing through a specific part of a stream is called the stream's discharge, okay? All right. So you can see that as the water flows in, it slows down, right? Because that's what it says here, it slows down. And when it slows down, the heavier eroded pieces of rock get dropped first. And then as the stream slows down a little bit more, then the next one goes. And then a little bit more, and then the next one goes. Until finally, all the way out until the middle of the lake would be the smallest piece. That'd be the furthest out. Okay? So that's what sorting sediments is. Flowing water moves the eroded rock, and when it deposits them according to size and weight. Heavier ones get deposited first, and then the lighter ones go further and further out until it slows down so much the water, they get deposited. Okay? All right, so let's move on to the next page. Let's see, is that right? Yeah. Okay. Glaciers, sediments, and valley shapes. Here's a glacier. Okay. A glacier is just like a stream, a river, but it's very, very big. Okay, it's very big. But it's also frozen. But wait a minute. I said it's just like a stream, right? So if a stream flows, so does a glacier. A glacier flows also. The difference is a glacier flows really slowly, very, very slowly. Okay, it still moves, but really slowly. So you can see what I wrote here. That we know that flowing liquid water and eroded rock material, eroded rock material and sediment deposit. I'm sorry, let me read that again. Eroded rock material and deposits it as sediments in another location. I should rewrite that. A couple of typos in there. Okay. But what about solid water? In other words, ice. Well, a glacier is like a stream with one big exception. A glacier is a frozen stream. But just like a regular stream, the glacier flows as well. Okay. But much, much more slowly. So here I drew a picture of a valley. Okay. And in there is a glacier. I hope that it's clear. All right. And what I did was I put parts of like rock chunks in there, right? You could see that the rocks are eroded rock particles, right? And they're frozen inside the stream. So as the stream moves, well, these rock particles, they move with it, okay? Let's read down here. It says, as a glacier moves slowly over many years, it breaks off pieces of rock, which are these in here, and the rock particles in the glacier are angular in shape. In other words, they have angles. They have points on them. So if you look at all of these pieces in the glacier, they have points on them, and they're like, angles and things like that. They're not smooth and rounded like a stream. Okay, that's a big difference right there. Flowing water will round a rock sediment. Frozen water, like a glacier, will keep them angular. It won't smooth them out. So it says here the rock particles in the glacier are angular in shape. Angular means pointy and sharp-edged. This is different from eroded particles in a flowing stream. Remember, a flowing stream has eroded rock particles that are smoother in shape. Okay? So that's the difference. Let's take a look back here. Look at these sediments, nice and round, right? In water. Look at these. These are all angular, pointy, sharp-edged in ice in a glacier. Okay, so that's one of the big differences between flowing water and frozen flowing water. Okay, all right. Now here, what happened to the glacier? What happened? Well, it melted. Okay, the glacier melted. It says right here, melted glacier, and that's the water in the melted glacier right there. What do you notice about the sediments? What do you notice about all these rock particles? Are they sorted? No, right? They're unsorted. They're not arranged according to size and shape and weight and density. So, in other words, as a glacier moves, it carries its sediments with it. But when it melts, it just drops them right there. It doesn't say, okay, it's not like a glacier's gonna be like, all right, I'm melting now, so let me let me put the big ones first, all right, and now let me put the next ones, and no, it doesn't do that, right? When it melts, it just dumps everything right there. So here you can see glaciers deposit sediments unsorted, not in layers either, right? And angular in shape. In other words, they are not arranged by size, weight, or anything, and they're all pointy. Okay, so that's what this picture is here. Let's move on. Valley shapes. Okay, so if you look here, a valley, right here, a valley is an area of low-lying land, right here, that is in the middle of two higher areas of elevation. Okay, now if you notice, the two pictures that I drew here have two different shapes. And a glacier, right here, creates a U-shaped valley. Okay, not to be confused with a me-shaped valley, but a U-shaped valley. Get it? Me-shape, U-shape. No, all right, never mind. Okay, so here, U-shaped valley right there, like the letter U. That's what a glacier creates. That's how you know a glacier used to be here. But look at a river or a stream. A river or a stream. That's a V-shaped valley. V, right? Like river, R-I-V-E-R. Well, a river creates a V-shaped valley. A stream, a river, a brook, things like that. Those are the differences between the valley shapes. One is U, one is V. Okay? That's how you know what used to be there. All right, let's move on. Streams and meanders and stream channel shapes, and oh boy, this seems complicated, right? No. Super duper easy peasy. All right. Let's take a look here. Meander. Not to be confused with you-ander, but meander. Never mind. Okay. And I know you guys miss my jokes. I know you do. All right, meander, right here. Meander is just a stream that goes back and forth like this. It meanders. All right. Most streams do this. If the water's moving very, very quickly, high velocity, right, it might go straighter. But slow moving water just meanders. Okay. So here we are, made a little picture of a meandering stream. And I went ahead and I marked these two areas on the sides of each meander. Over here on the right, it says the outside of the meander, where the curve is on the outside, it has faster stream velocity, so you get more erosion. The faster water moves, the more it's going to erode, right? The more it's going to take away rocks and dirt and stuff, right? Well, then the opposite must be true, right? Here, on the inside of the meander, the inside of the curve, it moves more slowly. Slower stream velocity means, well, what's the opposite of erosion? What was that? Yeah, good. Deposition, right. So you get more deposition, more depositing, putting in place. So the slower it moves, the more sediments it's going to put there. The faster it moves, the more sediments it's going to take away from there. Right? Okay. Let's see. Let's see how this works. So here on the inside, it starts like looking like this, right? Like that. On the inside, it's moving more slowly. So these little things I put here represent sediments being deposited on the inside of the meander. Over here, the same thing. On the inside of the meander, we have deposits getting put in. So that means that on the outsides, where the big arrows are, outside of the meander, faster, more erosion. So what happens is this gets pushed out further. This gets pushed out further. So you start looking like this, and then you end up looking like this, where on the inside it's much, much further in because of all the deposited sediments. And on the outside it's much, much further out because of all of the eroded sediments. Okay? Inside deposition, outside erosion. Inside is slower, outside is faster. Okay? So you end up looking like this. Okay? You got this? You sure? Let's see. Here's a question. All right. I'll read the question, and I'll give you guys a moment or two to figure it out. It says here, look at the meandering stream below. Based on what you know about stream velocity and its ability to erode or deposit sediments, choose the stream channel bottom shape that may form between points A and B. Now let's think a minute. Point A is on the outside of a meander. Point B is on the inside of the meander. One of these erodes and one of these deposits. Now, out of choice 1, 2, 3, or 4, which one out of these 4 do you think the bottom of the stream will look? Okay, this is a cross section of the stream. This is the way the bottom of it looks. Okay, I'll wait a moment. Maybe you want to hit pause on the video too. Okay, I'll just wait a moment. Okay, ready? I'm going to reveal the answer. You ready? There it is. The answer is A, or I'm sorry, it was 1, choice 1. Why? Well, I gave you a little explanation here at the bottom. So let's take a look. You know what, maybe I can zoom in down here. How about that? How about we zoom in a little bit? Okay, and then get my ugly face out of the way. How about that? Much better, right? Okay. So here we are. Whoops. There we go. All right. So points A and points B. A is on the left, B is on the right. Okay. So if we look over here, A is on the left, B is on the right. Okay. And these are the trees right there that I put so you can understand where we're looking. All right. It's a little difficult here. Hold on. I'll figure this. There we go. Figure this out. Maybe I need to zoom out a little bit. There we go. That's a little better. Okay, sorry about that. Okay, here it starts out looking like this, right? This is how the stream bottom looks before erosion and deposition. It's just a regular, nice shape, okay? All right, but over time, on B, it's moving slower. Therefore, the deposits, right, the deposition occurs along B. So it builds up, builds up, builds up, more and more dirt, more and more rocks. But at A, over here, see, it's moving faster. It's on the outside. So instead of depositing, it starts to erode away those sediments, right? It cuts into the ground. It cuts into the bottom of the stream, okay? So what happens is, here, how the stream looks at the bottom, right? That's the gray line. So what happens is it ends up looking like this over here at B. A is where it's moving faster, so the stream gets cut this way because it's more erosion. And over here, it comes up because it's more deposition, right? Right there. So that's the explanation for this here. All right. Let's see. Sorry about that. Okay. Let's go back. Let's review everything that we've talked about. Okay. Right here. Oops. Sorting sediments. Sorting means to arrange by size, shape, or weight, or any kind of feature, right? In what we're talking about is going to be by size and weight and density, that kind of stuff. And we know that a flowing stream, as it enters a larger body of water, like when a river enters a lake, or when a river enters an ocean, right? That river, the speed slows down. And as it slows down, it deposits the heavy sediments first, then the lighter ones, then lighter, 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 until finally it's the lightest ones it deposits last. A glacier is a frozen stream. Okay, but just like a stream, it does flow also. It moves, but very slowly. But when a glacier melts, it does not sort sediments. It leaves them unsorted, unarranged. Okay? They're also not smooth. They are pointy and angular and sharp. Okay? A stream and a glacier make two different kinds of valleys. A glacier makes a U-shaped valley, and a stream makes a V-shaped valley. Okay? If you have trouble remembering this, think of it like this. A stream is the same thing as a river. A river is spelled with the letter V, right? R-I-V-E-R. Well, V is what a river does, or a stream, right? Okay. Meanders, stream meanders. That's just a stream that, kind of flows back and forth like that. Okay? On the outside of the stream, it moves faster, the water. More erosion. On the inside of the stream, it moves slower. More deposition, more depositing of sediments. Okay? And as those sediments get deposited, and as those sediments get eroded, right, it changes the shape of the stream, right? The shape of the meander. Okay? It starts out like this, and then it starts going like that, right? Okay. And here, this is the stream bottom, right? The bottom of the stream. And where it moves faster is where it's going to erode, and where it moves slower, it's going to deposit. And that's why here the answer is 1. A moves faster, therefore it erodes more. B, it moves slower, therefore it deposits more. And down here's that explanation. Okay. A here, it's moving faster, so it erodes it away. B, moving slower, so it deposits and builds up until finally it looks like this. Okay. Easy, right? All right. Tell you what. Let's do let's do the first question together. I don't want to do any more than the first question. Okay, so here it says the block diagram. We can zoom in on this, right? Let's zoom in on that a little bit. Okay. The block diagram below represents a meandering stream. Okay? It's a meandering stream. And it shows you the inside and the outsides of the curve. Good. Okay. Move this out of the way. Which table indicates where the greatest stream velocity and the greatest rate of stream erosion occurs? Okay, so what is velocity? What is stream velocity? Stream speed. Good. Okay. Make my face a little smaller. Oh yeah, that's way better. Okay. So let's see. On the inside of the curve, well, on the inside of the curve, is it faster or slower? On the inside. On the inside, it's slower. So if it's slower on the inside, does it deposit more or does it erode more? As a stream moves more slowly, it begins to deposit. That's what it is. So it deposits, right? So the slower the stream, the more deposition. The faster the stream on the outside, the more erosion. Okay. So let's see. Let's see, greatest stream velocity on the outside of the curve. Yep, that's true. On the outside, it's the fastest. Let's see. And the greatest stream erosion is on the outside of the curve. I think the answer is A. Outside is the greatest stream velocity. And the greatest stream erosion is where it's the fastest, so that's also the outside of the curve. More erosion and faster moving water here. Greater stream velocity, greater erosion, both on the outside. Answer is A. Okay, the answer is A. All right, everybody. You have, I think, 13 questions here. And I think there are three questions that are fill-in, which are question number 8 is fill-in, and questions 12 and 13 are fill-in. Okay, this is due on Monday. Okay, 9:30. This is due Monday, so that means, yeah, you're going to have to do it over the weekend, but it's easy. It's easy. You probably have it done by Friday night. Okay? All right, everybody. Good luck. Email me or Google Voice me. Any questions, I'm available all the time. Okay? All right. Good luck.